Hi, Jobbies. So this is the fourth lesson in trigonometry. So today we'll be winding up on like the first part of trigonometry. So the first part is this introductory that we've been looking at, and then in part 5 we'll now do trigonometric identities. So these the 6 trig ratios. They'll actually introduce us to those identities. So we'll need the knowledge later on. Okay, and then we're also going to look at more on quadrants and more on special angles. So we can get started the 6 trig ratios. So in part 4, I introduced these. I just listed them, and then today let's discuss them. So the basic trig ratios that we know, we have cos theta, we have sin theta, and we have tan theta. Okay, so these they have relatives. So we now have other trig identities, which are sec theta, cosec theta, and cot theta. Okay, so these are the 6 trig identities, 6 trig ratios. So now, how are they related? So like the way I've listed them, that's how they are related. So starting with cos. So cos theta, what is cos theta? Yeah, so I hate writing this theta. It's taking up my energy. So cos theta is equal to 1 over sec 1/sec theta, and then sin theta is equal to 1 over cosec 1/cosec theta. Okay, I hope you're able to see properly. And then the last one, which is tan theta is equal to 1 over, so don't be lazy, you should be writing tan theta. Tan theta is equal to 1 over cot 1 over cot theta. Okay, so these are the relationships. So you can actually swap. You can also write sec theta to be equal to 1 over cos. So like you can make this sec the subject, it comes this side, and then cos goes down there. So sec theta is equal to 1 over cos. So you can write it in your book. Even here you write cosec theta is equal to 1 over sin theta. And the same here. So are we moving together? So one thing here is the challenge that I had, and usually most students have, is remembering which one is for which. So like if you have, so usually you'll be given this, you'll be given sec, let's say sec x. What is this sec x? You have to remember, okay, sec goes with cos. So sec x is equal to 1 over cos. So the angle here, we get it the way it is. Like if we have sec x, we also write 1 over cos x. If we have theta, we write over theta. So sec x is equal to 1 over cos x. Are you lost? Take a deep breath. This is baby stuff. Yeah, so just take note this, that. So now I want you to know how to remember them nicely. So like if you look here, sec, it's ending with a C. So it is related to the other trig ratio which starts with a C. Are you seeing that? Also cot. So here I told you we can make one thing, or we can make the other the subject. So like here cot, we can write cot theta. So we're going to write cot so we'll write cot theta is equal to 1 over tan. 1 over tan. Yeah, so for now you're able to see these. Yeah, so I'll make sure you're able to remember them very well. So the first hint is if you look at this cot is ending with a T and tan is starting with a T. So they are related. So any of these can be written as a reciprocal of the other. Cot theta is equal to 1 over tan. Or we can say tan is equal to 1 over cot. Yeah, so they can switch positions. So right now you have known 2. I've told you like here sec. Sec is ending with C and cos is ending with a C. So sec is equal to cos. That's the relative. In Nyanja, what do we call relative? Babuludo. Okay, so and then for this one, for sine, very cumbersome, like it's ending with a C, so that trick isn't helping. So this sine, it is different because it is coming from the word sin. You see, so sine. Remember when you sin, you go down. So now here we're going to say, for us to remember the relative for sine, we're going to say that what is this word? Okay, we're now getting vulgar. We've started insulting. Okay, so for sake, at least if you're saying this word, try to slang so that it doesn't sound like an insult that much. So for sake is a sin. So don't be saying for sake. It's a sin. Why should you be insulting? Can you tell someone for sake in front of your parents? So for sake, it's a sin. So this was just something to help me remember when I was learning trigonometry. I came up with this because for sake, it's sounding similar to this cosec. So cosec, the simpler form, we just write CSE, cosec. So cosec just sounding like forsake. Yeah, I'm even proud. I'm insulting. Yeah, man, sorry. This is for learning purposes. So forsake is a sin. So this should tell you something. Oh, forsake is a sin. So this sin, 1 over forsake, 1 over cosec. I hope I've helped you come up with something. So school is all about seeing what will work well for you, how you remember things. You can draw a chart. Yeah. So for me, mnemonics and these to my word plays, they are so helpful for me. So for sake, sine over cos. So the mistake which you'd make is like you want to write sine and then you write sine is equal to 1 over sec. If you do this, you're automatically wrong. Whatever you'll be solving down, it will just be something else. So sine is 1 over cosec. Remember, full sec is a sin. At least I hope I've delivered something. So we have introduced the three trig ratios. So these two mega tips, you can actually be writing them down in your book. When you're revising per last minute, you know that pressure that comes in. So we have now known that cos goes with sec. So if you have cos y, it's equal to 1 over sec y. So cos is sec, sine is full sec, cosec, and tan is cot. Alright, so that's the summary. So now what that relationship means, when you have a fraction, you can actually turn it around. So like let me give you an example. If you have cos 1 over 2, so cos goes with sec. So cos 1 over 2, it is just like sec, but they swap. Cos 1 over 2 is equal to sec 1 over 2. Yeah, this is the relationship. It's just like when you write cos 1 over 2 is equal to 1 over sec 1 over 2. You start changing things. Yeah, so this is the relationship when we have fractions. Yeah, you can use this. Even sine, like if you have sine negative 3 over 5, sine goes with cosec. It will be cosec negative, the negative is just in front, and then we have 5 over 3. So obviously you know if you have tan 1 over 8, it is just cot 8 over 1. Alright, we have introduced the 6 trig ratios. So what's next? What's next is we can start answering some baby questions. Okay, so do you remember in part 1 I told you that hold on to this, we'll come back. So we are looking at this tutorial sheet. Yeah, so and I actually made a mistake when I was answering last time. So for those who went through, so this the answer here is first quadrant, even here. Oh, it's second. I'm repeating the same mistake. Second quadrant. So I hope you remember how we answered. If you don't, you should revise or you pick it up from where we're starting from. So this is now taking us to our other objective. So want to do more on quadrants. So what do we have to say? So we have these. So like first let's draw our quadrant. So remember the mnemonic I gave you, which was like all students take chemistry. You remember that one, ka? Okay. So we can start answering already. So let's deal with this one, question C. So I only answered the first two. I said we'll continue later on. I fulfilled my promise. So tan theta is greater than 0 and cot theta is less than 0. So in which quadrant do we find this condition? So tan theta greater than 0. If something is greater than 0, you should automatically know that it means it's positive. So tan theta is greater than 0. Alright, tan theta is greater than 0. So where is tan positive? So tan is positive in here in here all students are positive. So all students take chemistry. So tan, so each of these trig ratios, they are positive in here and somewhere else. So for tan, it's positive in these two. You see, yeah, so tan is positive in the first and in the third. So we know that our answer can either be third quadrant or it can be first. So what about the other condition? The other condition, they are saying cot should be less than 0. Okay, so cot should be less than 0. So where is cot negative? So at this point you have to remember cot. What does cot mean? So we've said cot is related to tan. So cot is 1 over tan. Okay, so for this one, you simply get to check. So cot, you know this relationship. Cot is 1 over tan. So it simply means the signs for cot, they are the same with for sine. I shouldn't lose you here. The sign for cot, it is the same as the sign for tan. Because what is cot, you can simply say 1 over tan. So we have to check. So we want to satisfy this condition where we say cot is less than 0. So meaning cot is a negative. So where cot is a negative is simply where tan is a negative. So where is cot a negative? So cot is positive in here. All the ratios are positive here, and in here for tan, that's why it's positive. So meaning why it's negative, it's here and there. So to answer this question now, we have to check where do we find two signs whereby the other one is positive, the other one is negative. So where we find that is there's no quadrant. Yeah, so this one, it didn't have an answer. So we can say no quadrant satisfies this condition because cot is negative in here and in there. But in these two, we don't have where tan is positive. Yeah, so we have to make sure we see that, okay, tan is positive. We have seen, okay, tan is positive here and there. What about cot? Where is it negative? Cot is negative here and there. So we don't have an intersection. So the answer is where we have two values. Okay, so let's proceed to the other one. It should make things even better. Alright, so I hope you really write somewhere, because if you write somewhere and then we encounter such, you can just go back to where we first discussed. You remind yourself. Now if you don't write anywhere, you have to go back to the video, and then that's bundles for you. So question D, we have sec theta is less than 0 and tan theta. Sec theta is greater than 0. Somewhere there. Sec theta is greater than 0 and tan theta is greater than 0. Okay, so sec and tan are greater than 0. So we want to find the quadrant where sec is greater than 0 and tan should also be greater than 0. So we draw our I always don't know what this is, our Cartesian plane. Okay, so we have to check where is sec greater than 0. So sec, it ends with c, it's relating with cos. Alright, so you have to remember that sec is equal to 1 over cos. So here what they are saying, sec should be greater than 0, meaning sec should be positive, which also simply means that where is cos positive? So cos is positive in here. In here, all of them are always positive. So in here, cos is positive, all students take chemistry, and also here cos is positive. What about tan? Where is tan positive? Greater than 0 meaning positive. So tan is positive here. All students take chemistry, and there. So you see we have two signs in the first quadrant. So the answer is quadrant 1. Alright, that was a baby question. I wish we started with this one, because this one very satanic. Let's go to the last one. Cosec greater than 0 and cot greater than 0. So I've finally answered the whole question 1 for the tutorial sheet. So cosec greater than 0 and cot is greater than 0 as well. So we draw our this, that. So where is cosec greater than 0? Remember, sine, full sec is sine. So this one is an insult. It's relating to sinin. So cosec is 1 over sine. So, or if so here they have said greater than 0, meaning it should be positive. So where do we find sine to be positive? Sine is positive here, all students, and there. And then what about cot? Cot is relating to tan. So where is tan positive? Tan is positive there, all students take. So tan is positive here and here. So the answer is first quadrant. Okay, so let me add another one. Yeah, so you've understood here. So what if we had what if we had this should be negative? How could it have come out? Cosec less than 0, cot is less than 0. So let's work it out. So I have to check where is cosec less than 0 and where is cot less than 0. So starting with cosec, where is sine less than 0? So in here it's positive. Even here sine is positive, you know, all students. So in here it's positive. And then in here that's why sine is negative, and there. You're following? So sine is negative in here and there. Cosec relating to sine. And then cot theta. Cot, where is cot negative? You simply check where tan is negative. So cot ends with a t, is relating to tan. So tan, in here tan is positive, and then in here only sine is negative. So meaning in here tan is, in here only sine is positive. Only sine is positive here. So you can actually be writing that Catherine, all students take chemistry. Yeah, so in here tan is negative, and it's also negative there. In here it's positive. So in such a condition, the answer is quadrant 4. Okay, so the fourth quadrant. We have finally learned the whole lot of it. So alright, so we're still dealing with more on quadrants. Yeah, so we've actually learned a lot more than is necessary. Yeah, we've learned more than necessary. So the big deal of trigonometry is the identities. Yeah, we're getting there. The foundation is equally important. So now let's discuss something more on the quadrants. So more on the quadrants. You remember your SOHCAHTOA. Okay, so we go back to the roots. Okay, so if you have a right angled triangle like that, and you have an angle here, angle theta. So this side is the opposite. Where the angle is facing, that's the opposite. And the angle opposite the 90 degrees, the angle opposite this one, the side opposite this angle, it is the hypotenuse. And then we have an adjacent. So you remember very well that the mnemonic, this one is a very famous one. It's even found in textbooks. SOHCAHTOA. SOHCAHTOA. So this one, it helps us to know the trig, the fractions. So let me even just highlight in red. So we have SOHCAHTOA. So this is a T. So what is this SOHCAHTOA for? So this SOHCAHTOA is like if you want to determine sine theta, this sine theta, it is opposite over hypotenuse. So like if the opposite here, if we have like 3, there if we have like 5, sine theta is equal to 3 over 5. You see, whatever number is on the opposite and what is on the hypotenuse. So sine theta is 3 over 5. So let's say here we have like 7 on the adjacent. C is for cos. So we'll say cos theta is equal to, adjacent is this one here. So adjacent 7 over hypotenuse 5. Or you can write A over H. Yeah, so this was just a review. Tan, it is 3 over 7. Alright, so this was just a review. And then now let's answer another set of tutorial sheet questions. Okay, so this is our this is question 5 of the tutorial sheet. Okay, so I've made progress already on question 5. Let's do these satanic questions. They rarely come, but they can be multiple choice or something like that. So just a quick one. I will say they are saying use the basic trigonometric identities to find the remaining trigonometric functions. So like question A, they've given us sine theta is equal to this, and then they're telling us that it's in the first quadrant. So what they want us to do is they're saying we should find the remaining trigonometric identities. What that means is like we have sine, so you have to find cos, you should also find tan, you should find cosec, you should find cot, you should find sec. There are a lot of them. Yeah, some questions are boring and tiresome. I think I won't even answer everything. I'll guide you. So they're telling us that for the first question, it's in the first quadrant. Okay, so in the first quadrant, it means it's somewhere here. You see, so in here we have sine theta. So we're going to draw our that. Yeah, so we can draw this thing, and then so we definitely have an angle somewhere here. We have an angle. So sine theta is 4 over 5. So here you have to remember your SOHCAHTOA. So for sine, it is opposite over hypotenuse. So we're forming up a triangle. We're like working backwards. So opposite, it is the one on top. So for sine theta, it is equal to opposite over hypotenuse. So the number which is on top, it's the opposite. So like 4, so meaning this side we have a 4. You see, so that side we have a 4, and then hypotenuse is 5. So this is the right angled. This is the right angle. So the angle opposite the hypotenuse. That's where we have the the angle which is opposite the right angle is the hypotenuse. So like if you wrote down the triangle, that one you are able to see. You can also go back in the video. Go back. So this is the hypotenuse. So the hypotenuse is given as 5. So our hypotenuse is 5. So they have given us this condition, and then they want us to find the remaining trig identities, or the trig functions rather. So sine we have, let's find cos. What would be cos theta here? So according to SOHCAHTOA, the cos theta is adjacent, so the adjacent side is this one. So we have opposite hypotenuse, the remaining side is adjacent. So for cos it's adjacent over hypotenuse. So but the adjacent we don't have, we have to calculate it. So first thing, we calculate the adjacent. So we have a triangle. It's like this here. We have this triangle. Here we have 4. Here we have 5. Want to know the adjacent side. So you should be able to remember that the hypotenuse, the square of the hypotenuse is equal to the opposite. It is opposite squared plus adjacent squared. My mouse is slippery. Okay, so adjacent squared. Adjacent squared. So what is the hypotenuse? The hypotenuse is given as 5. Opposite, it is 4. And then we have the adjacent, which we don't know. We write it with a square. So we have 25. We have 25. So this is supposed to be 25 is equal to 16 plus x squared. So when 16 goes to the other side, it will be 25 minus 16, which should give us a 9. So 9 is equal to x squared. Okay, so we can find the value of x. The value of x is plus or minus 3. So x is equal to 3 when we square root both sides. So the adjacent is 3. We now know it. So from here we can draw our triangle again. We had what did we have? This. Okay, so this is our right angled triangle. So want to find the trig ratios, want to find tan, cos, and everything else. So do you remember what we had? We said this is 5, this is 4, and then this is now 3, and there is our angle. So we just find the 3 trig ratios, and we find the common ones, and we can find the other ones. So starting with sine has already been given. They told us it's 4/5. I hope I'm correct. Yeah. So sine is 4/5. And then what is cos? Cos theta. So remember SOHCAHTOA. I'm going to write it again here. Don't worry, you can write it a million times in your paper. Even the hand rule, you can write it. They won't penalize you for writing something that should help you to answer. So cos, it is adjacent. The adjacent is 3. So cos theta is 3 over hypotenuse 5, and then tan theta. So remember, I'm just feeling lazy to be writing theta. In your book, be writing sin theta is that, cos theta is that, tan theta is SOHCAHTOA. This is supposed to be O. What did I even write? SOHCAHTOA. This is OA. So tan is the opposite over the adjacent. So it will be 4/3. Yeah, but I make these videos when I'm so tired. I hope I haven't made a mistake somewhere. Alright, so from here now we can find the other trig ratios. Remember, sine, when you say full sec, that's a sin. So it goes with cosec. So cosec will be 5/4. You just swap them. This one was 4/5, this will be 5/4. And then cos, the one which ends with s, it deals with sec. So in your book, write sec theta is equal to, since we had 3/5, we're going to have 5/3. And then cot will also be the opposite here, 3/4. Alright, so this question is very involving and you rarely see these. So where did we even start from? Okay, so I don't think I'll answer all of these. I don't like lengthy videos. So what can we do? Let's quickly, okay, let's answer B, C, and we end there. So we have the question B is cos theta is -5/13, and the terminal side of the angle lies in the second quadrant. Okay, so we have the quadrant. So they're telling us that it's going to be somewhere here. Yeah, that's why it is actually. So in the second quadrant in here. So this is why we have our theta, and we can join up here. So we have been given cos. So cos, from our mnemonic, you should be able to remember it's SOHCA. So meaning the number on top. So we have adjacent over hypotenuse. So our adjacent, it is this side. So like you always have to know, like, opposite the angle. No wonder it's called opposite. This is the opposite. And then this is the right triangle. This is the 90 degrees. Opposite the 90 degrees, that's where the hypotenuse is found. But if you have problems identifying, you screenshot, you let me know. And while there are some, like if you notice an error, you let me know, like, oh, how did that happen there? Okay, so adjacent is 5. We have 5. The adjacent is 5. So this side is the opposite. So the adjacent is 5. The hypotenuse is 13. Okay. So for this negative, for the negative which is in front here, you can actually give it to what? You can assign it to -5. Yeah. So but the negative is just telling you that cos is somewhere where it is negative. Yeah, and if you remember, we say all students take chemistry. So with that, then what does it mean? It means cos in here, cos is negative. Yeah, no wonder we have cos theta is 5/13, but with a negative. Yeah, and then for the previous example, it just happened that it was in the first quadrant. This was the first quadrant. So all of these, they are positive, positive, positive. But here, we are even going to see we have negatives, positives. Okay. So, what do we say? We are going to want to find the other trig ratios. So the first thing under these type of questions, you have to identify which side hasn't been given. So like if you will notice, the opposite isn't given. So we have to work it out. So let's calculate the opposite. So we know very well that the hypotenuse squared is equal to opposite squared plus adjacent squared. So the hypotenuse is 13. So we'll say 13 squared is equal to opposite, we don't know. We can put x, or we can just write O. Yeah, you can do anything. So the squares, if it's z plus adjacent it's 5 squared. So we can find the value of x, where we say 13 squared is 169 minus 5 squared. When it comes this side, it's minus 25. So we have x squared. So you have to do what is 169 minus 25. Remember, no calculators. So x squared is equal to, when you subtract these two, you get 144. And the square root of 144 is 12. Remember, don't be lazy. You have to show all your working. So this is the part where students lose marks. You have to show, okay, I did this, I did that. This cancelled with this. Okay, so x is 12. So if we go back to our xy plane, this opposite, it's 12. This is 12. So when we have something like this, we can even find, so like, yeah, let's find the trig ratios. So what do we have? We have our triangle like this. Okay. So oh, it's not looking like this, sorry. So it's in the second quadrant. Is it? Okay, yeah. So we have here, we're saying this is 12, this is 13, and this was 5. And this is our theta. So starting with sine theta. Sine theta, it is opposite over hypotenuse. You should always remember your so ka toa. So sine theta is opposite, the opposite, which is 12. Sine theta is 12 over 13. Yeah, because this is the hypotenuse opposite the right angle. So where this corner is pointing, that's the right angle. Okay, and then in the second quadrant, so what we have is basically this. We're in the second quadrant here, and our triangle is just like that. So this is the second quadrant. So sine is positive in the second quadrant. We leave our answer like that. We go to cos. Cos, so cos is adjacent. What do we have as our adjacent? We have 5 over 13 as the hypotenuse. And then in the second quadrant, always remember, all students take chemistry. In the second quadrant, only sign is positive. So it means cos, we'll write it with a negative. So this was the question. We have re-answered the question. And then the last one, the last one for the basic ones, tan theta is tan opposite over adjacent, which is 12 over 5. Here, opposite, and the adjacent is this one. And then tan is negative, so write this as negative that. Okay. What else? We write the relatives, the family members. This one, who likes singing, the uncle is Fusek. So cos theta is 13 over 12. And cos goes with sec. So negative 13 over 5. And then this one goes with cot, negative 5 over 12. Okay, so maybe this can be 3 marks. It can come, but the main deal of trigonometry is now where we're going. Okay, so I've answered the following. The other one, I'm not going to do this one. So this one, why can't you try it? Yeah, so try this one. You can show me some if you want to like confirm. Actually, it's your exercise. So I'm starting with for you. So you draw the Cartesian plane, and then they are telling you that it lies in the third quadrant. I don't know if you saw the question. This one, question C, it lies in the third quadrant. So in the third quadrant, which is here, yeah, in the third quadrant. So meaning we have our that there. So our angle, it is this one, like a helping angle. And then we have that. Okay. So this is the opposite. So, and then we have been given tan theta is 12 over 5. So tan is toa. Opposite this. So let's move it a little bit. So opposite the angle, we have, it means we have 12. And then adjacent is this one, which is 5. So always remember, your right angle triangle is the one that has hypotenuse. So it means here you have to find the hypotenuse You find the hypotenuse, and then that's when you can find sine, tan, sec, cos, blah blah blah. Okay, so you answer that on your own, and then this one is very satanic. I don't even want to answer it. Cosec is negative 5 over 4, sec is less than 0. So for question D, we have they're telling us that cosec is negative 5 over 4, and then sec theta is negative. So sec goes with cos. So it means where is cos negative? Cos is negative here. Yeah. Devil, you are a liar. In here, all of them are positive. Sec is negative here and there. You just have to know where is cos negative. It means that's where sec is also negative. It is in these two. And then if you look at cosec, they are giving you a hint that cosec is in a quadrant which is negative. So where is cosec negative? Cosec is negative in here and in there. Okay, so I'm now talking like you are now experts. Yeah, because you are almost there. You are close to perfection, and even myself, I'm not perfect. So let me just answer with you this one so that I don't become a bad tutor. Cosec is negative 5 over 4. Sec is that. Okay, so here is our question. Question 6 is an exercise. Thou shalt solve. It's a very baby question, you guys. There's no way you can't solve this. Oh yeah, but feel free to let me know when you are stuck or you are done. Come here. So I want to answer with you this one, because in here this is the one which they can even ask you in a quiz or something, because they are not telling you it's in the third quadrant, it's in the what? They have just given you conditions and they're like uzamuziba yesu. So what have we been given? They're telling us that cosec is negative 5 over 4. So simply meaning that cosec is in a quadrant where cosec is negative. So cosec, it goes with sine. Remember, full sec is a sin. So where is sine negative? Sine is negative in here and in here. All students take chemistry. Sine is positive here and there. So meaning it's negative where it's not positive. Okay. And then sec is less than 0. So where is sec less than 0? Remember, sec is related to cos. So where is cos less than 0? In here it's positive, in here it's less, in here it's less. Here cos is positive. So this means that this condition or this question is in the third quadrant. Are we together? Yeah, so that's what they meant to say. Instead of just telling you that it's in the third, they were like, you figure it out on your own. So this is our triangle. This is the shan. So what have we been given? We've been given cosec is 5 over 4. Okay. So they'll give you one thing and then they'll be like, find the rest. Cosec theta is 5 over 4. So it's quite difficult to know, okay, this is what, this is what. So for you to work with this, you should be able to convert it to sine. Remember, cosec is related to sine. So this means this will be sine 4 over 5. Oh, sorry. Sine theta will be equal to 4 over 5. Okay, so when you have this, then you'll be able to remember. So, from Sokatoa, the opposite, this one which is being opposite to the angle. So meaning the opposite is 4. And then hypotenuse, it is opposite to the right, to the 90 degrees. So the opposite is 5. So you can find the adjacent. And how you find the adjacent, you simply say, okay, I'm tired of the formula. 5 squared is equal to x squared. Yeah, you can start with x plus 4 squared. So when you solve nicely, what are you going to get? You have 25 minus 16, which is 9. And then square root of 9 is 3. Okay, so I've just done it comma fast. So here we have a 3. So I'm about to conclude. I don't want it to hit 1 hour. Okay, so from here we can find, like, they've given us cosec already, and then for sine it's automatic. We've already figured it out. Sine, it's 4 over 5, but in the third quadrant sine is negative, so don't forget a negative. And then what about cos? Cos SOHCAHTOA. Cos is adjacent, which is 3. Cos is adjacent, that adjacent 3 over hypotenuse 5. And tan, tan you can manage. Tan SOHCAHTOA, opposite of adjacent. Opposite is 4. Why do I write this? Okay, I will squeeze here. But please don't write madongo-dongolish like. Okay, I'll just wrap this. I hope you wrote it down. Okay, so tan theta is, so from SOHCAHTOA, tan theta is opposite, this opposite over adjacent, so it will be 4 over 3. And then you should never forget the signs. So for cos theta, in the third quadrant, cos is negative. We put a negative. Tan is positive. All students take. So you can find the others. Cosec, they already gave us negative 5 over 4. And then cos goes with sec. Sec, it's negative 5 over 3. And cot, cot is 3 over 4. Alright, so this is where we break off. It was a lengthy one. Make sure you wrote something. Okay, so I'll take you back to our objectives. Also, we haven't met the target I wanted us to reach, so we just remained with like a small part, special angles. And on these special angles, there was that question in part 3. I don't know if it's part 2 where I said convert this because you might regret if you don't. Okay, yeah, so this is where we're going. This is where we were going. Okay, so going back to the tutorial sheet, we've made some progress. We've answered the whole lot of question 1, question 3, the question 2, the whole lot of it. You can answer these baby questions. Yeah, we discussed all these. This is the importance of writing. So and we've answered the whole lot of question 5, and then question 6 is where the other lesson will focus on. We now deal with the trig identities. So more on special angles. Yeah, we're going to do like a small video on this. I'll answer question 4. Okay, so until next time, it's bye bye. So we wish you a Merry Christmas. Oh, the date is December 25th. Okay, so Merry Christmas. Yeah, Merry Christmas and happy festive season.